Let's talk about complex numbers. Now, before we get into complex numbers, we're going to talk about something that was proposed by a pretty old mathematician named Rene Descartes. And that was, he wanted to talk about, well, what if I have a negative number inside the radical? Up until this point, that's been pretty much voodoo. We didn't want to ever have a negative number inside a radical. And so what he said was, well, what if I take a value like the square root of -1 and I give it a name, and I'm going to call that I. Okay, and what he did was he created what we now call an imaginary number. I has a value of the square root of -1. Now, with that in mind, what if I is equal to that, what would I squared equal? Well, I squared, since I is the square root of -1, if you multiply square root of -1, or I times the square root of -1, remember, I'll kind of put it off to the side here. Remember, I squared is the same thing as I times I. So that means that's the same thing as the square root of -1 times the square root of -1. Well, if I multiply those, what we get is -1. So I squared is equal to -1. I added a third. Well, I added a third is equal to I squared times I. Well, if I squared is equal to -1, I is just equal to I. That means I added a third is equal to -I. And if we continue on, what would I added a fourth be? Well, I added a fourth is the same thing as I squared times I squared, which is -1 times -1, which is 1. What if I did I added a fifth? Well, I added a fifth is the same thing as I added a fourth times I. I added a fourth is 1. I is just I. And what you'll see, and we can continue on in this process, is that as I go down, if I go from I squared is -1, I added a third is I added a fourth is 1, I added a fifth is I. And so we're kind of going right back up to here. And if we continue down with I to the 6, I to the 6 would be equivalent to -1. I to the 7th would be I to the 8th would be equal to 1, and it continues on. And so these first four are a cyclical pattern or a repetitive pattern. As I continue on, the values of I just continue to repeat over and over, and they repeat in a series of 4. You go from I to I squared, I to the third, I to the fourth, I to the fifth is equal to this, I to the 6th, 7th, 8th, I to the 9th is equal to this, I to the 10th, 11th, 12th. And so because of that, you can then figure out what numbers like, or values of I are, like I to the 6th. I to the 6th would be the same thing, and now if we just wanted to go through and just count, I to the 1st, 2nd, 3rd, 4th, 5th, 6th. I to the 6th is the same thing as I squared, which I squared is equal to -1. Now, if I have a number like 31, I don't want to have to go through and count. I'd hate to have to go 1, 2, 3, 4, 5, 6, 7, 8. You know, you could for a number like 31, but what if I, instead of 31, I said 31,000? Well, you're not going to be able to count all the way through. So an easy way to do it is this. Since the pattern occurs in sequence of 4, 1, 2, 3, 4, then it repeats 1, 2, 3, 4. What you can do is you can take 4 and just divide it into 31. And what that's asking is, how many of these 4-step sequences here occur in 31? So what you do, 4 goes in 31 7 times. And the remainder is what you're concerned with. And what that tells you is that you would essentially, if you were to count, you'd have to go through this pattern 7 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, etc., etc. You have to go through 7 times. And at the end of the 7th time, you'd be here. And then the remainder says then you'd have to go up 1, 2, 3 more. So essentially, I to the 31st is equal to I to the 3rd. And since I to the 3rd is equal to -I to the 31st is equal to -I. So you just take 4, you divide it into here, and you look at your remainder. And whatever that remainder is, that tells me that I to the 31st is equal to I to whatever this remainder is. And there you go. Pretty simple. The same thing if you want to go backwards just for a second, we could have done it for this one. You know, 4 divides into 6 once, and you have a 2 remainder. So that means I to the 6 is the same thing as I squared, which is what we said, which is negative 1. Okay, so if I know what the square root of negative 1 is, it's I. Okay, we're not going to leave an answer with a negative radical, just like you've always known. That means I can actually do a few things with when I have numbers that are negatives inside the radical. So for instance, it says simplify. So what would the square root of negative 1 be? Well, that would just be I. Anytime I see the square root of negative 1, I would just say I. Okay, what about this one? Well, the square root of negative 8, that's the same thing as the square root of negative 1 times 8. And the square root of negative 1 times the square root of 8. And you know that square root of negative 1 is I. And you know the square root of 8 is 2 root 2. Okay, so if I put those together, I would just write 2I root 2. Pretty simple. Okay, what about this one? Well, let's see. If we kind of take what we did over here, the square root of negative 3, well, this, remember, that's the same thing as negative 1 times 3. And square root of negative 2 is the same thing as negative 1 times 2. So the square root of negative 1 is I. Square root of negative 1 is I. And I can multiply. So I get I squared root 6. But I squared, if you go back up here, is equal to negative 1. Excuse me. So square root of, or probably I squared is negative 1. So my final answer is just negative root 6. And that's something that you should always do. You should always simplify your i's. If you have anything that isn't I squared, I to the third, I to the fourth, etc., you should simplify that. Now, kind of a common mistake on this one is people tend to do this. They say, oh, well, I can just multiply those together and I get root 6. But the answer we came up with was negative root 6. Now, why is this not the result? Well, the reason for that, well, I guess just a kind of simple reason for that, is you can't multiply these together because these are impossible numbers. We don't know what the square root of negative 3 is. We don't know what the square root of negative 2 is. So in order for us to do something with it, we have to convert them into I values. And so that's why it's important to convert square root of negative 3 to I root 3 first, and the square root of negative 2 to I root 2 first, and then you can do something with it. So this is not true. Okay, a couple other ones. What about 2I times 5I? Well, multiplying I values isn't any different than multiplying just variables. I would just multiply 2 times 5 is 10, and I times I is I squared. The only difference is I need to simplify that, so I squared is negative 1, so my final answer is negative 10. Same thing with this one. I can multiply. Negative 3 times 6 is negative 18. I squared times I to the third is I to the fifth. And so I to the fifth, we've already done it luckily up here. It's the same thing as I, so it would just be negative 18I. Again, anytime that you have an I value, it should never have an exponent. You'll never have an answer that has I squared, I to the third, I to the fourth, I to the fifth. You should always simplify it down. Okay, so what does this do for us? Well, what it does is it helps us solve problems that we couldn't solve before. And so what you'll see now is you'll see a direction like this, solve, but then in addition, you'll see this, over the complex numbers. And what that means is an answer that you could have now, what you couldn't have before, would be a possible imaginary value or a complex number, something that I know we have not talked about yet, but we will in just a moment. So how do I solve? Let's talk about this. Well, I obviously would subtract 4, and I get x squared equals negative 4. Then I would square root, and then so this is x. I would get plus or minus. Now here, square root of negative 4, up until this point, we would say, oh, that's impossible. So I have no solutions, or no real solutions is what you would say. And that's true. You don't have a real solution. You have an imaginary solution. Because the square root of, remember, negative 4, this is like a negative 1 right there, so that would be I. And the square root of 4 is 2. So I would get plus or minus 2I is my answer. Up until this point, this would be a problem where you would say no solutions or no real solutions. But now that we know imaginary values, we can actually give an answer to it. It's just that this imaginary number is not part of the real number system. So let's try another one. What about this? I would subtract 162. I would divide by 2. X squared equals negative 81. Square root, pretty simple. X equals plus or minus. Square root of 81 is 9. The square root of negative 1 is I. Okay, pretty straightforward right there. Nothing super complicated. Okay, the only difference being that before these would have been no real solution answers, and now you actually can get a solution. It just happens to be an imaginary value. So that leads us into what is this thing called complex numbers? I mean, it says complex numbers here, it says complex number here. Let's talk about it. Well, a complex number is any number that can be written in the form of a plus bi, where a and b are real numbers and I is imaginary. So a complex number is essentially just a combination of a real number and an imaginary number together. An imaginary number is just that imaginary value that we've been dealing with so far. A complex number involves a real number also. So for instance, this is a complex number. Why? Because it has a real number here and an imaginary value right there. This is a complex number because here's our real part, here's our imaginary part. Again, complex, complex. If this over here didn't have the 8, then that would just be an imaginary number. But you put this in there, and now we call it a complex number. So not too different than imaginary. Okay, so let's talk about how you simplify this. Well, you don't do anything different than what you normally would. If you didn't know anything about I or imaginary values, what you would do is you would just distribute this minus sign into here. So that's what I'm going to do. So I'm going to distribute it in, so this becomes positive, this becomes negative. And then I'm just going to combine. 8 plus positive 12 is 20. 7i plus a negative 11i is minus 4i. Okay, and then that's it. And the way this is written, okay, this is what we call a plus bi form. And that's something that you need to get used to. And you'll talk more about it the more you deal with complex numbers. Is you write the real number part first, the imaginary part second. Okay, so let's do this one. So it's saying multiply complex numbers. Well, you do it just like you would think you would. You're going to go through and distribute that or FOIL that. And so 4 to this would be 8 minus 12i. Down here, you get 10i. Here, negative 15i squared. Let's clean it up a little bit. 8 minus 2i minus 15. I squared is equal to negative 1. So it becomes 8 minus 2i plus 15. So to write it in a plus bi form, I'm going to combine these two. So I get 23 minus 2i. Okay, so complex numbers, not terribly challenging, at least what they are. Remember, it's just a combination of a real number plus an imaginary value. Now, imaginary numbers, that's what we talked about the most, you know, the biggest thing is knowing that I is equal to the square root of negative 1. And as long as you know that, you should be able to figure out what these are. And that just opens up a whole new world to us, something that we haven't been able to do to this point, where now we can deal with numbers that are inside radical numbers, or inside of radicals. Okay? Thank you.